Hi, eighth graders again. Basically getting done with this last section. Um, 1.90 sets. Um, so basically we're going to be working with a set of numbers today. We're going to look at rational numbers a little bit and well, not so much irrational, natural numbers and so on, and kind of how we can group them. Going back kind of like to English a little bit, you're going to have Venn diagrams and that stuff. So, first off, there's kind of our objectives for the day. You guys usually don't care too much about them. First off, empty set is when there are no elements in the intersection of two sets. So you're going to be given two different things, and nothing in those two sets are going to be the same. Intersection is the region that is in both circles of the Venn diagram, symboled by N. Well, that's going back to if you had a diagram there. But you guys have did Venn diagrams probably in English a little bit, maybe not. Basically, you have two circles, and this is going to be the point in which both circles are going to meet, and it's going to be which is in both circles. Subset is a part of a set. Its symbol is a U that is rotated 90 degrees. Now, a subset is going to be a smaller group inside of a larger group. For example, if you had 1, 2, 3, 4, 5, it could be 2, 3, 5. That'd be a subset of the original one. Union is shown by the symbol U and indicates the combination of sets. So that kind of means like how we used to look at it when I was in college, I think, was and. You have this and this. It's both of them put together. And then a Venn diagram can be used to illustrate the relationship of the sets. Venn diagrams, as you might need a quick reminder, and I've already started talking about somewhat of this. And so this is a Venn diagram. And this is your intersection. Right here. That would be your intersection. Okay. Now going to example 1. Use notation to denote the set of even integers. Well, integers, if you can remember, are basically any number you could put on the number line that is not a fraction. So you could start out with, let's say, -3. Oh, we got to be even though. So let's go to 2, -2, 0, 2, 4. Now, to make this a subset, or not a subset, to make this a set, usually you have to put them in brackets of some type. And obviously I can go ... here, and that would be everything. So that's how you'd set up a set. Now, if it said, for example, odd, you just put odd in there. Or if it said positive evens or positive numbers, you just got to basically know what you're looking for and then put it in there. Okay. So, as this reads, you're going to have this E kind of looking thing that looks a little more rounded, indicating elements. 3 with this E is integers. Well, is 3 an integer? Well, it's a counting number and it is not a fraction, so yes. So this reads 3 is an element. That's why you use that, or E, rounded E, because it's an element of the set of integers. Now, 1/2 is not an integer because it is a fraction. So this one reads 1/2 is not an element of the set of integers. Okay. Now, let's go over here. We are looking at use the set notation to indicate whether each number is an element of the set of rational numbers. Well, what is a rational number? Well, the first one, rational numbers can be quotients. You really got to go back, and maybe you'll have to look this up. Maybe I should have put that on there of which each one is and can it be inside of another one. In this case, number 2, you have -1. Do we think that would be an integer? A rational number? Okay. So basically, if it can be written as a fraction, can we write -1 as a fraction? Well, we can put it over 1, that works. So this one is -1 is an element of rational numbers. Okay, then can we make this one okay, can we make 2 a rational number? Well, we can put it over 2 over 1, which then is going to be a fraction. So U2 is an element of rational numbers. Okay, how about this square root of 3? And right off, you might be like, oh. You might be like, well, I don't know about this, plus square root of 3. Square root of 3 looks like this. Okay, is that a rational number? Well, it's not really a fraction, it's going to be a repeating decimal. So square root of 3 is not an element of a rational number. Okay. So, like I said, rational numbers can be written as fractions. I put this one over 1, so then you could. Okay, now, example 3 here. Graph the element of each set on a number line. The set of integers. Well, set of integers, and it can keep going on forever and ever. 0, -1, -2, -3. Those are all integers, your counting numbers. Okay, they're numbers we can use to count. Also, all these numbers would be rational because we could put them over 1 and make it, but in this case we want integers, not rational numbers, so we're fine. Okay, I guess I made my line longer this way. And so on. Okay, so that would be graphing the elements of a set on a number line, and this would be a set of integers. Now, B, we'd have to have the square root of all these. Well, the square root of 1 is 1. So square root of 1, square root of 2, which is actually 1. So we got a point there. Okay. You have square root of 3, and you have the square root of 4. Now, the thing is, we know the square root of 4 is actually 2. Okay. So we got a point here. Now, these are going to be somewhere in between here. So I'm not 100% sure. I could type them into my calculator, but I know they have to come in between here somewhere. So I'm just going to throw them in there, and it's going to be pretty well done. Oh, and you didn't get to see much of that. Sorry about that. I should pay attention to the camera a little bit. So yeah, basically what you got going on there is you have numbers that are square rooted, and like I said, like this one and this one, I know they have to become in between those. So I just kind of filled them in. Okay, this is what we've been talking about. Rational numbers are counting numbers. 1, 2, 3, 4, 5. Integers are going to be anything that you'd put on a number line. Negative, 0, 1, going in both directions. Rational numbers, we've already talked about, is going to be numbers that you can write as a fraction. And then we have real numbers. Real numbers, trying to think how much more complex they are. I think they're natural numbers, which are the smallest one. Rational numbers are only going to go from 1, 2, 3, and so on. Oh no, that'd be natural. Scratch my thought on that one. Oh, so real numbers are going to be any number, even like the square root of 3 or square root of 4 or square root of 2. Them are all going to be real numbers. Real numbers are basically even got rational or irrational and rational numbers. And rational would be every one of these would be rational. Irrational would be like the square root of 2, square root of 3, and that so on. And I know that kind of gets tricky. If you have to, look those up. Just because of the fact that they are a little trickier. Okay, now going to this, use the subset symbol to show the relationship between a set of natural numbers and a set of integers. Well, integers are going to be all the numbers, -1, so on, where your natural numbers are not going to be all those. Those are going to be like 1, 2, 3, and so on. So, in this case, you're going to have n, which is your natural numbers. Oh, that is the big category. Natural numbers. Natural numbers are 1, 2, 3. Okay, and I was thinking about this wrong because I was thinking, well, integers are bigger, so, but this is going to read natural numbers are a subset of z, which is your integers. I was thinking the other way around, and actually, if you go down here on this, which is what I should have looked at right away, this sideways u is a subset of. So n, being the natural numbers, is a subset of integers. Okay. Now this is the symbols for a set of. Wish they would have brought it up in the lesson a little earlier, and I probably should have put it there. This should be the intersection of. Okay. So going to 5, it says set A and B are shown below. Find A and N and or A, B, and find A, U, B. So this N, going back, is the intersection of. So that's going to be, if we make a diagram right here, Venn diagram. Okay, what do these guys got in common? Well, this one has a 1, that one doesn't. This one has a 2 and a 4. They both have that. This one has a 3, and this one has, you get the 2, 4, and a 6, and an 8. Now, so, for the first part, it says find A and B. So, going back to English a little bit, when you have and, it means included. So, basically, you have to have the intersection of. So, the ones that they have both of. You can't just have some of them, they have to have both in this case. So, in both circles. So we need to find what is in both circles. Okay, so find A and B, what is in both circles? Well, 1 and 4 would be your A and B. Okay. I also apologize on some of this, and you're going to see it a lot. I'm using Google Docs and Google PowerPoint right now, and they're a little bit different than what the PowerPoint I use typically out of Word, because Word does a very good job for math on the aspect of keeping it the same. Now, it also wants to find A in the union of B. Well, the union, think of it as or. You don't have to have both. You can choose one or the other. So, what's going to take place here is basically everything that's in your Venn diagram is going to work for this one. So, you want to write all the numbers. So, find A in a union of B. Well, that means I want everything that's in common. Okay, in that case, you have 1, you have 2, you have 3, you have 4, and then you have 6 and 8. This is your set of this Venn diagram. And I'm about 100% positive you should put these in set notation. I don't know why I didn't right away, but I didn't. Okay, so there would have been a Venn diagram. It honestly didn't say I had to draw one, but, visual learners like to see that. Now, like I said, in both circle, So really, you could probably stop here and you could probably do 6 because it says use a Venn diagram to illustrate the set. Find A and the intersection of B, which once again is going to be all these everything that intersects. So it's going to be this middle part here. Okay, we have 1, we have 2, and we have 3, but we're working with natural numbers. Natural numbers. So going back over here, natural numbers, counting numbers. Oh, is what it says. So, counting numbers. Well, isn't 1 actually 1? Isn't 2, 3? Because this is A. Wouldn't everything technically be in there? And then you have N, which is or natural numbers. And that would go on 4, 5, 6. Oh. I need to make my Venn diagrams a little bigger the way it looks. And so on. Okay. So in that one, for A and B, so you would have the set of 1, 2, and 3, because everything in A would be both of these. Okay, now going up to B here. Once again, we're trying to find A and U, so we need to find the intersection. Hopefully I can make that middle a little bigger for you guys to see. Okay, so we have A over here and we have B over here. Okay, we have 2 in A and not in the other one. We have 4. We have 6. And we have 1, 3, and 5. This is kind of a different one. You don't have anything that is in the middle intersecting. So, going back over here to the chart, we have an empty set. This is when there's nothing in common. Okay? So, nothing in common. So you're going to say A and B equals 0 with a line through it. There's nothing that works with that. Okay? So, nothing too dramatic here. Maybe something you haven't seen, but I think you guys can work through it. It is going back to stuff we learned a while ago. It's kind of a little bit of a review with a little bit of a twist on it. Your assignment on this one, and I don't think it is on the back. Okay, I didn't think it was on the back. You got page 604, number 1 through 23 odds. Tomorrow you're looking at a test. You use open book test on that portion, just because of the fact that I want you to get it done. We'll probably also have you guys doing the investigation. I really haven't created any notes for the investigation. Most of the time, it's usually the end of after the test, so a lot of times I have you guys just do the investigation yourselves. And that's what I'm going to kind of do now, because of the fact that some of you guys might be done with that test in 20 minutes. Some of you might take 45. This gives you a little bit of flexibility, plus it gives you a little bit of homework on top of it. So, anyway, go ahead and give this a try. Once again, don't be afraid to get a hold of me if you have any problems. And the letter should imply everything there again, once again. Just reinforcing that of when I will be available, and other stuff like that. The test, I'm hoping to have your parents text me it or something, so it's basically done long before that, within hopefully about 3 hours. Either text me it, or also I'm hoping they'll put it in Google Docs or email it to me. It's up to them. But yeah, that's kind of where we're at on that right now. So yeah, like I said, I'm pushing on because of the fact that I think that it might be a while before we're back in school, and I want you guys to be ready for next year as can be. Obviously, some of this stuff might be a little harder without me in the classroom, but you guys are a pretty smart group, so hopefully you guys catch on, and hopefully it helps you for next year. Have a good day.